Hi, Joyce, Amanda, George.
Yep. Hi, everybody.
Oh,
Jackie
first try.
and Gerardo are going to go through the evens for 10-3, 10-4, 10-5 before we go over questions. I know you guys texted some. But let's figure out what the even answers are first before we keep going.
Hey, you, keep working. Do I have permission to beat this computer into submission?
Not totally beat, because I'm not sure it'll totally submit, and then I won't have a computer. But I definitely did beat it a bit this morning. It's getting really frustrating right now.
Alright. So the first even, 32, but wait, I think we already went over that one. For 10, this is 10-3. 32.
Did you guys grade 10-3 yet?
Part of it. We just didn't get to 33, 35, and 42. We can check 42 right now. Oh, shoot. I don't know what to make of this. Yeah. Nope.
So 10 is the smallest value of n for which the maximum, so 10. You see it in the second line far right?
Yeah. How do you
So
get
n
there?
equals 10.
How do you get there?
They use the graphing calculator.
Funny. Really funny.
Oh, they graphed, here you go, Jordo. They cheated and used the graph, because, that took a long time to type it all in. But they used the window from negative pi to pi for the x values and from 0 to 0.1 for the y values. So then they were saying which one is contained within 1/100, or which one is contained within 0.1, and the only one that was contained within was the second graph. And the second graph was the 10th degree polynomial. Because the first graph, it goes too high. It goes above 0.01, so the error is greater than. So they cheated and used the graph. I would have probably just used solving with the n plus first term.
Yeah, but then you have to use your calculator to figure out which.
Well, which they did. So it was a calculator problem. So either way, you could have plugged in different terms and figured out which one goes below 0.01, 1/100, or you can use the graph.
Okay.
I feel like the graph takes more time, but I'm not so sure about that.
Oh, duh. Okay. Okay. Oh, I really messed up. Okay. All right. Okay. Oh. Okay, so D. Oh wait. Oh, Miss D, did you ever finish D, 33D from yesterday? Because like, when I left, you were just like, it's a calculator problem, and they just did some random intuition thing right here, and it just makes no sense. It's like that.
Were we going over homework questions at the end of yesterday? I thought we were covering.
Well, you said we'd go over them today.
Oh, right. So you're checking the evens right now, right?
That we did. We did the evens.
Oh, for 10-3, 10-4, and 10-5?
Well, I didn't do 10-5, but all my questions on 10-4 are odd.
Yes, but did you go over the evens on 10-3, 10-4, 10-5, which is what I asked?
Oh.
Okay. So let's go ahead and make sure we keep on checking the evens.
Okay.
So otherwise we don't know what the answers are, so I'm not exactly sure that we got them right?
Yeah. All right, number 14. You know the There we go. Zero for 14. That's weird. It asks for a radius of oh, no. Never mind. It's right here. I had to read. 26. Cool, got that right. And 10-5.
58.
Oh, really? That's not good.
What, 58?
No.
You can just scroll up, sorry. It's okay,
No,
I do
don't-
it too. I'm not sure what else to do.
The Adobe Acrobat Reader DC has stopped working.
Okay, X. Isn't it a struggle? I agree. CalcBC on the far right side. Solutions manual. Scroll down chapter 10, or the one that ends in a 10. Got it. Today's technology just is not happy.
Alright, evens on 10-5. There's two evens. 44. Oh, yikes. Okay. Oh, that's weird. Alright, this one is just like you have to do it and check the endpoints. But Misty, what's this talking about? It says the interval convergence and converges absolutely. Does that mean like?
In this section, they were introducing the students, remember our chapter 10A is not in this book at all.
Right.
So they were teaching the kids about convergence and divergence tests at the same time as teaching the radius and interval convergences. So they're teaching the idea of absolute and conditional. However, I taught it only along with alternating series because that is the only time it is required of you on the AP. So we kind of kept it just with alternating series. So in this one, ooh, you can read that? Which one are you looking at?
44.
Is it alternating? No, it's not. Is it?
Hmm.
I can't see it.
It's
It's not alternating. So if it's not alternating, we say don't consider absolute or conditional. So they were asking for both
oh wait.
convergences, but for a non-alternating series where it converges, it will converge conditionally and absolutely. Wait, no, that's not right. This is not alternating. Converges absolutely on the open and conditionally at -4. I was just worried about letter A, especially since this isn't an alternating, that the AP wouldn't ask you to think about conditional absolute. Oh, there is an alternating sign. Hold on. Check at x equals -4. Oh, okay, they bring up conditionally absolutely because when you check at x equals -4, checking the test points, it converges conditionally at -4. That makes sense, because it's an alternating series. And it only works because it's alternating, right?
Right.
Okay. So they're just saying, if we're just talking about conditional, then we can include -4. If we're talking about absolute, well, it's going to be everywhere besides -4.
Okay.
Does that make sense? But then we put the two together and we say the interval of convergence is the closed interval from -4 to 4.
All right.
So that's okay.
Then 68. B. That's Misty. Since the x is in the absolute value, does that mean it's not? That doesn't mean it's
The x is
alternate.
always in the absolute value, right?
No,
mean
in the
it's
series.
alternating.
Oh.
That's just how we do interval of
Dough.
convergence with the ratio test, right?
Oh, dough. I thought that. Okay. Oops.
Is that okay?
Dough.
Okay.
Okay. Cool. That was 10-4-5. That's it. Oh wait, no, there's one more. 38. I can't count. Or I don't know my evens, I should say.
Oh, you're okay.
Okay, on this one, Misty.
Uh-huh.
When I was asking you for the where is this? The interval of convergence.
Mhm.
At 1/3, it converges conditionally.
Because it's an alternating?
Yeah. So does that mean it's closed interval 1/3 to open interval 1?
If it doesn't converge at 1?
Yeah, it's not converge at 1.
Yes. But if you're talking about conditional absolute, we would say conditionally is that negative or 1/3.
Yeah.
Conditional is at that 1/3. Absolute is everywhere else. But if we're just looking at interval of convergence, we would close the interval at 1/3.
All right.
Yeah.
Okay. Cool.
Does that make sense what they're saying?
Yeah. All right. That's everything. Now that's everything. And yeah. That's it.
So let me get one more example for algebra 1. So what questions do we need to go over? We're going 10.3 to 10.5 pretty much, right?
Yeah.
Can one of you guys open up your phone in the group chat since mine's being used for the microphone, and I know Amanda asked for a few specific ones. I don't know if anyone else did. Joyce or Amanda Devassarian might have also.
Oh. If you heard that crack on the audio, those were me.
That was your name.
Mm-hmm.
Here.
It was just Amanda Johnson. 33D, 35, and 42 of section 10. That's the same ones I have. And then 10-4, she doesn't know how to find the sum of the series as a function of x for 23 through 28 on 10-4. 23 through 28? I think she means 30, 23 and 20. 23, 27, 26, maybe. Because I don't have it. I had 23, 26, 27. I don't know what to make of this. But I think. Hold on. Let me just look at them real quick. Oh! Oh, she's talking. Yeah, she is talking about 23, 26, 27.
It's the same one.
Yeah. Autocorrect.
Okay, so let's go ahead and open up the book. Gerardo, hit on Google Chrome for me.
Google.
Are we starting in 10.3 or 10.4 from what you guys said?
10-3.
Okay.
I know the page number.
You could throw in that page number just so we have it.
509. Hey. Oh shoot. Oh. 33D was the earliest one. It's the same one we were doing yesterday. I think in the end you just needed to do a with your calculator, right? Because the math just got gnarly. You had to do like nth root of something.
You got it up and ready?
Yeah, it's up.
Let me check it out. Alright, we'll switch. So, 33. Let me grab my notes also so that we have extra space to work if we need it. What part specifically was the question on?
D.
.3. There we go. Alright. So I have my notes 10.3 and the homework questions that we're ready to look at. Let's add page below. Before we do homework questions, real quick, logistically speaking, our test is on Thursday. I have loaded into your guys' class folder a few things, including, there's your multiple choice. Oh, that's the packet. Hold on, that doesn't help. That should be in handouts and assignments. There we go. But the key to the AP multiple choice for Chapter 10, that's what's due tomorrow, if it opens. I do have the key for it for you guys to go ahead and be able to check. That way you can come in, and the answers are at the end as well. But that way you can come in with intelligent questions as to what you know you truly didn't understand. You are also going to get tomorrow a blank packet of different possible free responses that have shown up in the past from the AP. This is not specifically due for the day of the test or Thursday, but it is something that we can talk through really quickly. So the answers are already up for the FRQs. If you guys have a little extra time, you want to look at some of the FRQs just to be ready. The blank packet, once again, we're not doing the whole thing tomorrow, but it gives us another way to study. And I've actually decided not to give you a chapter review, but instead between the multiple choice review and the blank FRQs you can play with the answers online, I think that gives you more than enough practice. Okay, for the test on Thursday. The test might actually end up being 2 parts. There are going to be multiple choice, but there are also going to be some free response. And if we need to, we'll split it up into 2 days. I'm hoping we don't need to, but we might. I forget exactly how much time it took last year, so just giving you a heads up on that. Otherwise, let's go ahead and get out of your shared folder. Number 33 was the question that first showed up in section 10.3. Letter D. Gerardo was just starting to talk about it. So we do have a rational function. Burp, 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 burp.
Yeah.
D with the error. I think this was the one that you were asking, I think after class got out. Wasn't that right, Gerardo?
It was after school yesterday.
Oh, after school yesterday. So for number 33, just so that we have the information to be working from, we do have the function 2x over, was it 1 plus x squared?
Yes.
Okay. You guys should have been able to make that a series, and what did you guys get as your series?
Like the integral of that?
No, as the power series for this function.
Oh, in that case, 2x minus 2x cubed plus 2x to the 5th minus 2x to the 7th plus ellipses plus negative 1 to the n, 2x to the n plus
1. But you also need your negative 1. Okay. At some point along the line, they wanted you guys to find ln of 1 plus x squared, which would have been the integral, and they had you walk through that entire process, right?
Yes.
And what did you get when you integrated? What was that power series?
x squared minus 1/2 x to the 4th plus 1/3 x to the 6th minus 1/4 x to the 8.
Nth term would have been?
No clue.
We could have done 1 over n plus 1, right? Was it 1/2, 1/3, 1/4?
0. Yeah.
Okay. And then we could have done x to the 2.
2n plus 2, I think.
Yeah, 2n plus 2. And then we could have also done r times negative 1 to the n.
0. Yeah.
Is that right?
Yeah. That's good.
Okay. And letter D, they were asking us to think about error. And as we're noticing, This is an alternating series. They're asking us at ln of 5/4, so we're thinking such that x equals 5/4. I think they had you do some stuff up above about, oh no, it's leading up to this point. So if we're thinking alternating series, error bound, we can just think of, which should be easier, that or Lagrange?
Oh, alternating series would be definitely easier.
I thought it would be easier as well, because we don't want to take the nth derivative. Okay, so, or the specifically, where were you supposed to stop in letter C?
First four non-zero terms. It would be the
1, 2, 3, 4. Okay. So technically we're stopping here. Because I don't think they actually go through solving.
No. They just do some random intuition check and guess.
Right. So if we're trying to think about ln of 5/4, what would x equal for letter D? What would x equal if it was ln of 5/4?
5/4?
No. I think this might have been what I didn't see quickly when we were looking at it. Because if it's ln of 5/4, then doesn't 5/4 have to equal 1 plus x squared?
Yeah.
So what would x equal?
Duh.
1/2, right?
Oh, duh.
Oh, wait, where'd it go? Did it disappear? Sorry.
Yeah.
So ln of 5/4 comes from ln of 1 plus x squared, therefore x has to equal 1/2, which is a little bit nicer to plug in, right? So we're trying to figure out which approximation would be less than 1 over 100.
Oh, God. That's a pretty easy thing to miss.
So we could go ahead and plug in and we could say, okay, what is 1/2 squared? Right? That totally changes everything because 5/4 is greater than 1, 1/2 is less than. 1/2 squared is 1/4. Well, that's not greater than 100. We could do 1/2 squared minus 1/2 times 1/2 to the 4th. Let's see, we could pull out a 1/2 squared. I think ultimately they said you could use your calculator on this one, but that would be, what, 1/4? Minus 1/32nd? Still not going to be less than 1 over 100, true? Then we could go to the third partial sum, so we'd have 1/4 minus 1/32nd plus 1/3 times 2 to the power of 6, or 1/2 to the power of 6. That'd be 8 and 8, 64. 64 times 3 would be 2 and 1, 108? No, wait, I got that wrong. 64 times 3. 2, 1, 18, 19. 192nd?
I got 186. 64 times 3, so. Oh, 64 times 3.
Right?
Yeah.
2 and 1. Oh, 256. Duh. What was I doing? I don't know. No, I was right. 196. Right?
Yeah.
Okay. Hey, 1 over 196. That looks less than, right? But how do we have to compare it?
Add it to the rest of the.
Yeah, so then we'll have to say 4 into 196 is what? 2, 3, 4, 49?
44. 4 times 4 is
49?
What?
Right?
What's wrong with my math?
Jackie, you get 49?
Yes.
Okay.
And the math is not
49 minus...
That's 49.
Yeah. 32 goes into 196, what, 6 times? No. Ooh. Nothing pretty?
Wait a minute. Oh,
Ew, that's not happy times.
36. This was non-calculator homework. It's freaking annoying.
So that'd be 50 over 196. Well, 50 over 196, so that wouldn't be less than 1 over 100, right? Because that'd be approximately 1/4.
It's 0.2. Yeah, it's 0.26. So it's definitely.
So that doesn't work.
Oh, wait. 32. Dang it. Oh, never mind. We're still in the same stink boat we were earlier.
Ugh. Oh, wait. What am I doing that's wrong?
Bad math.
No. What am I doing that's wrong? Alternating series. Error is less than what?
A sub n plus.
A sub n plus 1. S sub n plus 1 or A sub n plus 1?
A sub n.
A sub n plus 1. So what am I doing? I'm doing the partial sums. Do I need to do the partial sums?
No.
No, silly me. So therefore, the first partial sum, or the first polynomial approximation, so p of 1 of 1/2, that was our 1/4. Well, that's not 1 over 100. P sub 2 of, no, I want A. I'm still doing it wrong. A sub 1, there we go. A sub 1 is 1/4. That doesn't work.
N plus first term is x to the 2n plus 4 all over n plus 2.
True, but we don't really need that, right? Because we can just estimate. And we already did all the work that we need. When we had the second term, we just looked at him, right? Absolute values, just think about the positive. 2 to the power of 4 was 16. 16 and 2 is 1/32. That wasn't less than 1 over 100. A sub 3, we got our 1 over 196. Guess what we found? Winner, winner, chicken dinner, right? So our A sub 3 is going to be our A sub n plus 1. So we can fill this in. We can say, all right, cool. A minus ln of 5/4 is going to be less than 1 over 100 if we do our A sub 3. That works, right? So therefore, what would our A be?
The answers put A as 1 over 32.
You mean when A sub n plus 1 is 1 over 32 or A sub n? Because I am saying second degree polynomial approximation because this is the n plus first, right? So A would end up equaling 1/2 squared minus 1/2 to the 4th. Which would end up being, if we were to work it out, 1/4 minus 1/32, which would end up equaling 8 minus 7. I don't have the answer on me. I was hoping you guys would have it. No?
The only one thing that you did that I don't understand, it said that error, the A sub n plus 1 has to be less than the error.
Uh-huh. And isn't 1 over 196 less than 1 over 100? And 1 over 32 is not, so therefore we need the n plus first term to be the third term. Which means that our approximation, that's the n plus first, our approximation will be the second degree polynomial. Yeah, A equals 7 over 32.
The first term, you lost me because
Pause.
the n plus first term, right?
Pause. The A sub n plus first. So, if it was the first term, 1/4 is not less than 1 over 100. I can't use that one. The second term, 1 over 32 is not less than 1 over 100. I can't use that. If you want to, I can rearrange this a little bit and say, remember the error is less than your A sub n plus 1, which needs to be less than your 1 over 100. We're trying to find the right guy to work. So we start testing the terms. The first term didn't cut it. Stink. The first term didn't cut it. Come on. First term didn't cut it. Plugged in 1/2. 1/2 squared. Nope, not small enough. Second term didn't cut it. I plugged in 1/2. Nope, not small enough. Third term, when I plugged in here, that worked. So that means that n plus 1 has to equal 3, hence n has to be 2. So I used the second degree, I shouldn't say second degree, but the second Taylor polynomial. So all I wanted were the first two terms, because remember the sum of the first two terms is going to have an error less than the third. Nice thing is that's recorded so you guys can mull that over a little bit. Section 10.3, were there any other further questions that you guys had?
Yeah, 35. B.
Can you represent y by a power series? Okay, we're looking at number 35 real fast. We are trying to find in our problem, we're trying to think about the derivative, or the function whose derivative is equal to e to the negative x squared, right? Now, how do you integrate e to the negative x squared? Ooh, u sub doesn't work out so nicely, but can't we integrate the power series for e to the negative x squared?
Yeah.
Yeah. So we think about the power series e to the x, we plug in a negative x squared. To represent y by a power series, we just need to think about the following. We can take the integral. Y is equal to y of, what'd they give us? Y of 0? Plus the integral from 0 to x of dy dx, or of e to the negative x squared. So then we can represent y by integrating the power series. And we're going to add y of 0 is 2.
Right.
And when we think through that process, we would need to find e to the first. Then we would need to integrate, starting with 2 plus, then we would integrate each of these term by term by term, which they did, term by term by term. And they were just asking for, yet again, a power series. Oh, that is the power series. There we go. And did they ask for the nth term? Oh, not even. So that's okay. You could have just written the power series, but of course we can write the n plus first term because we have x to odd powers and we have, the bottom's a little bit messier. You would have had to think about your factorials to get a nice nth term, but they didn't actually ask us for this. This is sufficient. And then they're asking us about the interval of convergence. And remember, e to the power of has an infinite interval of convergence. So we can say that the new series or the integrated series will also converge for all x. That was kind of our idea from a few sections ago when we were talking about the Maclaurin series. Does that make sense? Cool. Any other questions from 5.3? From the text message or from, we got it all?
Did you go back to 35 so you can copy that in the
Oh, the answer?
There was C. C, power series.
Remember I talked about that one. Since e to the converges for all, the integral of e to the will converge for all as well. That was our shortcut from the Maclaurin series.
Yeah.
But we learned yesterday why the interval of convergence is what it is. Okay, we're going to section 10.4.
It's starting to get a headache.
Find the interval of convergence of the series within the sum. So we just do the n plus first term over the nth term, we end up with number 23. After taking the limit, oh, it's geometric.
Yeah.
They just cheated. So interval convergence is just take your common ratio, which is right there.
Yep.
Multiply both sides by 4, so you have between -4 and 4. We know it won't be or equal to, so we'll just test the endpoints. Then we can go ahead and square root both sides. So we'll have 2 and 2, and then we'll add 1. Sorry, -2 and 2, we'll add 1, we'll get -1 to 3.
But you can't take the square root of a negative number.
But with the absolute value, remember we're kind of doing illegal math in a sense. So for number 23, let's see, this is on section 10.4 now, right?
Did you?
Number 23. We would technically have
Right.
and when we're solving, these technically aren't equalities, these are inequalities. This is always true, right? So that doesn't really limit anything. Over here on the left, when we take the square root, wouldn't we have the plus or minus square root? So the positive square root would be 2. The negative square root. So Gerardo, we're not technically taking the square root of a negative number because on the on the right hand side, this is always true, so there are no limits. We're only looking at the right hand side. I'm saying everything backward, the left hand side. This has 2 pieces to it, plus or minus square root.
Right.
Right?
Plus, so plus 2 and minus 2. X minus 1.
So it ends up working out the same as if you had done the square root of a negative and pretend like you knew what it was. But technically it's all from the inequality work on the left hand side.
X minus 1 is greater than, why is it greater than -2?
Because whenever you introduce a negative in an inequality, the inequality has to flip for the exact same reason that when I had the -1 over here, it was greater than. Because in a sense, you're multiplying both by the negative. Any other questions on section 10.4, 10.5?
Yes. 27. Same exact problem.
Oh, if it's the same exact problem, then you guys are fine.
Yeah, no,
Number next one?
that's it.
Okay, and Amanda and George and Joyce didn't have anything further? Okay, cool. So I'm going to go ahead and close this down. I actually have to get algebra notes ready for the next class because I'm teaching them crazy factoring and I still haven't decided which way I'm teaching them. You guys know what you're doing for tomorrow. You are working or finishing up the Chapter 10 review, the answers for which I have shown you in the folder that are there. And then if you have time, you're looking at the FRQs. Sound good? We'll say yeah.